And it is this. We have been given those directions before. It says use the given 0 to find all zeros of the function and write the linear factorization. They are telling us a 0 of the function. Now, the weird thing on this one is the 0 they are handing us is imaginary. Yesterday, we talked about if we are told that we have an imaginary 0, what do we automatically get? The opposite sign, right? So that is the key to being able to do this, is that you remember that because they tell us this one, that also negative 5i is a 0 of this function, and that's going to be the key. You remember that they come as a pair, always, okay? Now, here's the part that's going to be ugly, is that we're going to do synthetic division, and we're going to do synthetic division with an imaginary number, which means all of our terms are going to be complex numbers. So in the middle of this problem, it's going to be ugly. When we get to the end, it's going to be pretty. And if it's not, something went wrong. Okay? So set up your synthetic division like normal. When you set this up, knowing that we're doing this with an imaginary, you're going to have complex numbers in there, which are 2 terms wide. Give yourself a little bit of breathing room in here. Okay, so the first time we just go through with the 0 they gave us, which is 5i, but we have to remember how to multiply and add with imaginaries. Remember that I can multiply anything together. So it doesn't matter if they are like terms or not. I can take 5i times 1, which would be 5i, right? And I put my answer here. Now, I'm supposed to add those 2 terms together. But they're not like terms, right? That would be like a -3 and a 5x. And so they end up just sitting next to each other when I add them together. -3 plus 5i. We get a complex number there. The process still doesn't change though. Now I take 5i times that and write my answer under 27. Now, to help you with your notes taking purposes, I'm going to show a little bit of work right here, but I'm also then going to erase it because I need to do synthetic division a second time. You may not want to put it right below like I do. You might want to put it somewhere else for yourself. But my next step is to take that 5i that's out here, right? Multiply the number right here, -3 plus 5i. So I'm taking that and distributing it through here. 5i times -3 would be -15i. And then 5 times 5 is 25. I times I is -1, right? I squared. So this ends up being 25 times -1 or -25. Okay, y'all follow that? All right, like I said, I'm going to erase this here. Now I'm supposed to combine my like terms. Well, my like terms are going to be the real number part of this. Combine like terms. So I will be able to put together the 27 and the -25 and get 2 minus 15i. And we repeat the process. We take that 5i, I multiply 2 minus 15i, distribute that through, so 5i times 2 would be 10i. 5i times -15. 5 times -15 would be -75, but I times I will be -1, so it ends up always being the opposite sign, positive 75. And a positive 10i. Okay. Now, I am able to combine my like terms again, which again will be the real number parts here. And you'll notice something. -75 plus 75, gone, right? Guess what? Always happens on that second to last number. Always. What you should be left with at this point should only be the imaginary number. Every time you do this. Good notes to take for ourselves, right? Because if it's not that way at that point, something went wrong before. I made a mistake with my arithmetic. At this point, the second to last number should only be an imaginary, not a complex, because watch what happens. 5i times 10i. 5 times 10 is 50. I times I is -1. so that I get negative 50. And just like we were expecting, I get a 0 remainder. Okay? Now, the process or the pattern that you just saw there is always going to happen. The second to last one is going to be a singular imaginary. We're going to end up with a 0 remainder. Okay? Then we have to do synthetic division a second time with its imaginary friend. Okay, so we just did the positive 5i, now I have to do the negative 5i, and that's the trick to this that we have to remember, is that although they did not tell us that one, we know it exists, and I repeat this process with that other imaginary, negative 5i. Okay, now as you do this one, it should clean up beautifully, and you should have no imaginaries left when you are done doing this one. And if you do, something's wrong, go back and try again. Okay, so negative 5i times 1 is negative 5i. Notice, as I combine my like terms here, the imaginaries cancel, not by mistake. That's going to happen every time. So positive 5i, negative 5i are the like terms we can put together, and it should be 0. So we are left with the real number, negative 3. All right, negative 5 times negative 3 would be a positive 15i, and again, my like terms are the imaginaries. One's negative, one's positive. They're going to go to 0. I am left with the real number 2. Negative 5i times positive 2. A negative times a positive is a negative 10i. Just like we were expecting, should get a remainder of 0. And like I said, it cleans up really pretty. So guys, it's like this 3 terms right here where it gets ugly. And that's the only 3 terms that should be ugly in this whole thing. It'll clean up beautifully here. We get down to some nice quadratic. Our last step is to write this out and factor. Okay, are there factors of positive 2 that add up to negative 3? Yeah, negative 2 and negative 1, yes. Okay, so let's go back up to the top. Yesterday you were introduced to this phrase right here, linear factorization, which means that we're going to write out all of those. You remember that on your assignment? We're going to write out all of those, including the i's, with an x to the first. That's what linear means. So all of our factors would be those zeros right there, 5i, negative 5i, and then factoring the x squared minus 3x plus 2. So our answer, let's go ahead and factor that x squared minus 3x plus 2 would be x minus 2, x minus 1, and then your imaginaries, x minus 5i and x plus 5i. Any questions on that? Okay, like I said, there are 2 examples today. That's the example I want you to follow, and now you're going to try this one on your own. Did you guys all see that that 16 had a subtraction in front of it that somehow floated up into the exponent? Did we catch that? I don't know why this subtraction is floating that high. Should be a minus 16x right there. Remember the key places that we are looking for things to happen on this. On that first initial synthetic division, your second to last term should be a singular imaginary, no real number. It should end up being 0 at the end. When you do synthetic division that second time, it should end up very pretty, no imaginaries left. 2i times 5 should be 10i. All right, let's go ahead and I'm going to go ahead and start talking through it on the board. Keep working if you're still working, but check with my work up here. 2i times 5. Remember, we can multiply anything together, whether they are like terms or not. So 2 times 5 is 10i, and then we start getting those complex numbers because I cannot add things that are not like terms. So they end up just sitting next to each other, -4 plus 10i. And then I will distribute the 2i through that term. So 2i times -4 would be a -8i. 2 times 10 is 20, but I times I will turn it into a -20 because it's a -1. And I combine my like terms, which would be the real numbers. 19 minus 20 would be -1 minus 8i. Repeat the process. 2i times -1 would be a -2i. 2 times -8 is -16, but the I times I will turn it into a +16. Combine my real number parts of it, -16 plus 16 would be gone. We're left with just the imaginary -2i, which is what we expected. 2 times -2 is -4, but the I times I will turn it into a +4, getting us a remainder of 0. Then I need to go through that process again using its imaginary friend. I used +2i first. Now I'll use -2i because they always come in pairs. -2 times 5 would be -10i, and my imaginaries cancel, leaving me with -4. A negative times a negative is a +8i, and again my imaginaries cancel, leaving me with the real number 1. Negative times a negative is a +2i, leaving me with a remainder of 0. Writing out my quadratic, 5x squared minus 4x minus 1. And then remembering that our answer is the linear factorization. So factoring that, and don't forget your imaginaries to write them as factors as well. So let's see, that would factor into 5x and x, -1 and +1. And also writing my imaginaries into factors as well, x minus 2i and x plus 2i. Good thing to check myself at the end here. Remember that we learned that we will have as many zeros / factors as we have biggest exponent. This will start out as an x to the 4th. As I look at my answer, I should have an x to the 4th. And if I were to multiply those all out again, I would have an x to the 4th. So little things like that that I can check myself, make sure that I'm not forgetting something, all of that. Now, before we move on to your assignment, which is a worksheet, I do want to point out there is a second option of how to attack that. I'm not going to go through it very honestly because it involves long division. And long division, it was a place, especially like on our last quiz, that people showed me that they tend to make a lot of mistakes. But I do want to point out it is an option, and if you like that option, you are welcome to use it, try it out, whatever. But for example, on that last one, if they tell me that 2i is a 0 of my function, yesterday we talked about, okay, well, if 2i is a 0 of my function, It came from the factor x squared plus, you remember doing this yesterday at the end of our notes, and then came from the factor x squared plus squaring the 2, x squared plus 4. Well, that's then a factor of our polynomial. So what I can do is long division using that factor, if you are preferring long division over that synthetic that we just did. And all that does is avoids having to work with those imaginary numbers or the complex numbers in your synthetic division. Here's why I don't love this method. Do you see how we're missing a term here? You would have to remember to fill that in. You would have to not make mistakes that a lot of people made during our long division, and then remember to factor this and put this back as linear factorization. So breaking that into the x plus 2i, x minus 2i. It works. You are welcome to use it. If you prefer long division, so you can avoid doing the synthetic, that's fine. Just be cautious and be very detail oriented if you do that way. Okay?